48 integral from 0 to 1 x square root of 2 minus square root of 1 minus x squared dx. This looks like a complicated composite function. Let me adjust the screen a little bit. Oh, not like that. Can I do any better? Let me shift this down a little bit, maybe. Good enough. Okay. So, as I was saying, this is a composite function. So maybe we want to do some substitutions to make it a little simpler. That's what I'm thinking right now. So let's let u be the innermost, maybe. So u is 1 minus x squared. We can square both sides first. U squared is 1 minus x squared. Then 2u du is minus 2x dx, which if we simplify, u du is negative x dx. Okay? I'll worry about our limits of integration afterward. So then we would have, we have an x dx over here, x dx, right? So then that would be negative u du. So now how should I write this? Minus u and then du at the end, okay? And then we have square root of 2 minus u. Okay? And then limits of integration, when x is 0, we plug into our definition up here. When x is 0, u is 1. When x is 1, u is 0. So we can get rid of this minus sign out in front and flip our limits. 0 to 1. Okay, so now what can we do from here? Maybe now let's do another substitution. V, let it be 2 minus u. So then dv would be negative du. Okay, so what about limits of integration afterward again? So u from here would be 2 minus v. So 2 minus v times square root of v. And then du is negative dv. So dv with a minus sign out in front. Now we have to change the limits again. When u is 0, v is 2. When u is 1, v is 1 as well. So we can, once again, drop the negative sign out in front and flip the limits from 1 to 2. Okay? So from here, we can just distribute that square root of v. So 2v to the half power minus v to the 3/2 power dv. Okay? This is a definite integral, so I can technically erase all this since I changed my limits of integration. Okay? I need space, so I'm going to shift things up now. So then this becomes 2 times 2/3 v to the 3/2 minus 2/5 v to the 5/2. We evaluate this from 1 to 2. So then this becomes 4/3 times 2 to the 3/2 power minus 2/5 times 2 to the 5/2 power. And then minus 4/3 plus 2/5, plugging in the lower bound. Let's box that and be done. Let's not bother simplifying that. Way too risky. Okay, so this is my answer. Double check if I got it right. I actually did not pre-solve this one, so I'm not sure if this is 100% correct. Should have checked beforehand, but if this is not correct, please feel free to leave it in the comments. But otherwise, this one, again, the thought process was it's a complicated composite function, so maybe let's do a substitution to make things look a little nicer inside the integrand.